I'm excited to welcome you to the absolute best video on concatenation and temperate literals you'll find anywhere on YouTube. In this video, I cover everything you need to know in detail and use interactive animations, beautiful illustrations, and professional editing to ensure you remain engaged in order to maximize your learning. So let's jump in. So the first thing we need to discuss is concatenation. So what is concatenation? It's joining two or more strings together using the addition operator. It looks like this. Here's my first name, Daniel, which is a string, as it's enclosed by quotation marks. We then use the addition operator. This now allows us to add the first string to a second string, which is my surname. And the result looks like this, Daniel Brand. And just a small note, you'll see there is no space between my first and last name, and we'll be seeing how we can achieve that soon. But this gives us now our concatenated string. That is, the addition of our two strings together. So let's go play around with this inside VS Code. So I've gone ahead and set up an index.html file with the boilerplate HTML and a script tag linking to app.js, which is currently empty. So I'm first going to declare a variable, let first name equal Daniel, and then let last name equal Brand. And I'm going to go ahead and concatenate these two strings in a new variable called full name. So let full name equal first name, which is the string Daniel, plus last name, which is the string Brand. So full name is effectively taking Daniel and concatenating it with Brand. I'm then just going to output this result to the console. So console.log full name. So let's go check this out in the console. So you can see here in the console, we get outputted Daniel Brand. Now, obviously, this is not how you'd write a full name. You would have a space between it. So there are actually a few methods to achieve this. The first is what we can do is inside the full name variable, we can add another string which just has an empty space like this, and then add a plus symbol after that. So now we're concatenating Daniel with a space plus Brand. So I'll save and I'll refresh the page. And now you'll see we get Daniel Brand with a space between it. Something else you could do is go back to what we had and then just put a space after the word Daniel. I'll refresh and we get the same thing. Now, one thing I want to do is get you a bit more comfortable using the console. Let's say that this variable is only being declared in order to output it to the console and not being used elsewhere in our program. This is then inefficient code. We're declaring the variable and then just using it to print to the console. So instead, what we can do is just output this directly. I can do first name and concatenate it inside console.log like this. So I'll save, I'll refresh, and you'll see we get back the exact same result. Daniel Brand. So the next important thing we need to get a good understanding of is how strings and numbers work together. Numbers displayed on web pages are actually strings, while the actual numeric data is used in calculations. Taking a look at an example on our EasyJet web page, in our basket, our current ticket fee is £563.44. You can see as well numbers are used in our fares down here, in terms of our fares for adults and children. So it's very common to output numbers onto a web page. Now these numbers in JavaScript that is used in our script and processed in the JavaScript engine is the number primitive value. So we can perform a calculation like this, in terms of calculating the final basket fare, which is 563.44. So numbers are used inside our script and processed inside the JavaScript engine for the purpose of calculations. Now on a web page, what's actually appearing here is a string. That is basket 563.44 pounds. Now this point is subtle, but it's important. All text that appears on a website is a string. It's not the number type. The number type is specifically used inside a script for the JavaScript engine to process. So while we do see numbers on a web page, what's actually being rendered there is just a string. So this brings us to the next important concept of type coercion. Type coercion is the automatic conversion of values between different data types. Now this conversion happens when we're using different operators. So let's first have a look at using different data types with the plus operator. JavaScript favors concatenation when one value is a string and the plus operator is used. So let's take a look at an example of this. If we have the string Daniel and we add 34, that is, we're using the plus operator with a string and number, what we end up with is the string Daniel 34. So you can see that when we have a string and number, JavaScript is automatically converting the number to a string and performing concatenation. Now this can cause some problems. Let's say we had the string 10 and we add the number 34. what we're going to get is the number 1034. And this is likely not what we want. When adding two numbers together, we're likely going to want to add them. That is, 10 plus 34 equals 44. But you can see what happens when one of your numbers is actually a string. So that's the plus operator. When you're adding a string and number together, JavaScript will favor concatenation and convert the number to a string automatically. So let's now take a look at the other arithmetic operators. When using minus, multiply, divide, or the modulus operators, JavaScript will attempt to convert any strings to numbers. So for example, if we have the number 10 multiplied by the string 5, we're going to get the result of 50. That is because JavaScript is converting the string value 5 to a numeric value, and 10 times 5 is the number 50. But now check out what happens when a string just can't be converted to a number. For example, 3 multiplied by the string hello. For the string hello, it's not possible to convert to a number. So the result we get is a number type called NaN, which stands for not a number. Now don't let the name confuse you. NaN is a special type of number. So even though it's called not a number, it is a numeric primitive value. So let's go play around with type coercion in VS Code. So picking up where we left off, I'm going to go declare another variable, age equals 34, and let current year equal the string 2025. So inside console.log, I'm going to grab first name, I'm going to add the plus operator, and then my age 34. Now this is a string being added to a number, which is a different type. And as we discussed, when a plus symbol is involved, JavaScript will favor concatenation when one of the values is a string. So I'll refresh in the console, and you'll see we get Daniel 34, which is the string value. Let's now go and use one of the other arithmetic operators to see what happens. Let's say I want to work out the year I was born. So I would do current year minus my age. Now current year is a string, and my age is a number. So let's see what happens. Inside the console, we get the number type 1991. Now the reason this has happened, as we've discussed, is that when using an arithmetic operator which is not a plus symbol, JavaScript is attempting to convert any non-numeric values into a numeric value. So the current year of 2025 is a string, but through type coercion, current year inside console.log is being converted into a number. So this ends up working. But we saw if I do something like first name minus age, where first name is just a string Daniel, Daniel is not going to be able to be converted to a number. So if I refresh, you'll see we get NaN, which stands for not a number. You'll also note that it is in purple, just like the number 1991 we saw before, showing that this is in fact the primitive number type. And as I mentioned, it's just ironic that it's called not a number, where it is in fact a number. Now, relying on type coercion can cause errors and become messy with many values and spaces. So let's say we had the variables first name with the string Daniel, last name with the string Brand, city with the string London, and age with the number 34. If I wanted to output a sentence on the web page combining all of these variables and using concatenation, it would look something like this. So let's read this through. My name is with a space plus first name, which would be Daniel, plus a space, plus last name, Brand, plus, comma, I live in with a space, plus city, London, plus, comma, I am space plus age, 34, plus space, and next year I will be space, plus the variable age, 34, plus the string 1. So it would be outputted like this. My name is Daniel Brand, I live in London, I am 34, and next year I will be 341. Now you're probably shivering in your seat, thinking to have to write this. It's incredibly messy. First of all, keeping track of spacing is annoying. There are a lot of pluses needed to construct this sentence, and it's also easier to make errors. Where over here, I'm adding the number age to the string 1. What I'm wanting to output is 35, but type coercion is kicking in and converting my age, 34, to a string, so we end up concatenating 34 plus 1, which gives us 341. Now, being able to output sentences like this onto a web page is really important, because as I mentioned earlier, we don't ever output numeric values to a web page. All text we see on a page is strings, including numbers. So we need an easier way to be able to work with numbers and strings in order to output them on a web page. And this is where template literals come in. I know that sounds like a scary word, but it is very simple. Template literals is a special string using backticks that allow for embedded expressions. So let's break this sentence down. When I use the word expressions, I mean anything that returns a value. And we'll see what that means in the example shortly. For backticks, it's a special character that's on your keyboard and looks like this. This is what a backtick looks like. For me on my MacBook, it's towards the bottom left and also has the tilde symbol above it. You might need to spend 20 seconds just trying to find this backtick symbol on your keyboard, as it isn't something you would have used a lot before. But what backticks allow us to do is construct our sentence like this, where we're no longer having to concatenate our strings using plus symbols. Backticks also allow us to use interpolation syntax, whereby we have a $, 2 curly brackets, and between the 2 curly brackets, we can put our embedded expression, which is anything that returns a value. When I say returns a value, I mean, for example, if we had declared first name Daniel in a script and went to the console and just typed in first name, we get back the value Daniel. So it's really easy to use backticks to effectively insert any variables into our text sentence. Now, the other really great thing of being able to use embedded expressions inside temperate literals is that you can perform calculations. So over here, I'm taking my age, which is a numeric type, and adding 1, also a numeric type, which would result in the value 35. When everything inside the embedded expressions have been calculated, this sentence is then all converted into a string type. So let's go play around with temperate literals inside VS Code. Alright, so I'm back inside our app.js file and I've just cleared everything here. I'm going to come and declare a few new variables. Let product equal laptop, let price equal 1000, and let tax equal 100. Now what I'd like to do with these variables is output to the console this sentence. The laptop is £1,000, but with £100 tax, it costs £1,100. So let's first achieve this with concatenation. I'm just going to be copying from this string to make this a bit faster. I'll first copy this part, add a quote, then plus. This here is the price of the laptop. So I'll grab price here, plus. I'll copy all of this up to the pound. This here is the tax. So I'll copy the tax variable, plus tax, plus adding quotation marks and copying from the space after the number 100 to the pound symbol over there. I'll paste that there. And then plus the addition of the price and the tax. So that is plus price plus tax. All right, for this result, I'm going to store it in a variable. So I'm going to go let result equal all of this. And then I'm going to output it to the console by doing console.log and adding in the result. I'm also just going to remove this sentence here. Okay, I'll refresh in the console and we get this laptop is £1,000, but with £100 tax, it costs this huge number here. So you can see that this, number 1, is very painful to do, and number 2 can lead to errors where type coercion is converting these to numbers, but isn't actually performing the calculation correctly. To achieve this correctly, we'd have to do something like this. Let total price equal price plus tax. And then I'd have to use this variable total price over here. So if I refresh, you'll see we now get the correct answer. Now just a note, just like I mentioned earlier, you didn't have to create this new variable result. You could have put this all inside console.log like this. I'll just comment out result for now. I'll refresh. You'll see we get the same thing. Now for me, I just find it a bit cleaner, not having all of this inside console.log. So I prefer working with the variables like this and then using it inside console.log. All right, let's now go achieve the same thing with temperate literals. I'll declare a new variable called let result to equal. I'm going to grab my backticks that look like this. And if you look at them carefully, they are quite different to quotation marks used on a string. So let's now go construct the same sentence. The laptop is pound symbol. And now I grab the $ and curly brackets. And inside here, I simply put the price. Space, but with pound symbol. Now I need to use the tax variable. So I'll grab the $, my curly brackets, and just put in the variable tax. Space, tax, it costs pound symbol. And now for the total price, I'll grab my $, and now I can perform this calculation inside the curly brackets. So that's price plus tax. I don't need to declare another variable, total price. So let's now also output this to the console. So console.log and then result to. So I'll refresh and you'll see we get the exact same result. All right, just a small spelling error on my part. This should be it and not its. So I'll refresh. and you'll see the string outputted is the exact same. But I'm sure you can agree with me, this method using temporal literals is 100 times easier than using concatenation. So let's take a look at temperate literals in action. On our EasyJet webpage, let's focus over here with the passengers on the flight. We'd have the variable let adults equal 2, let children equal 1, and let infants equal 1. As I've mentioned a few times now, on our actual web page, those numbers are not outputted as the number type but as strings. So to construct this sentence, we would use temporal literals like this. We'd use our backticks, and using the embedded expressions, that is the dollar signs and curly brackets, would pull in all our numbers, and then all of this would be converted into a string and outputted on the web page. Over here, where we have the sentence up to £400 off package holidays, in our JavaScript file, we could have a variable like let max discount equal the number 400. We would then use temperate literals to output a sentence like this. This would then be converted to a string and outputted on the web page. Let's wrap up the theory of this video by building a summary card, string operators. We looked at both concatenation and temperate literals. I'll declare a string let name equal Daniel and let age equal 34. Using concatenation, that is adding strings together using the plus operator, we can output a string like this, I am plus name and I am plus age, which would give us I am Daniel and I am 34. We discussed how this is not the best way to output strings because it's very messy and type coercion can often lead to errors. We then looked at template literals, where we can use backticks and embedded expressions to output strings. For a similar string, I could do I am, and then using our interpolation syntax, dollars curly brackets with the variable name, and next year I am age plus 1. And we discussed inside our curly brackets, we can embed expressions. And this would result in the string I am Daniel and next year I am 35. Now that you've mastered the theory so far in this video, it's important to understand how we can apply it in a real-world project. If you haven't been following along in other parts before this, I recommend you download the starter files in the description below and code along with me. This project is part of my JavaScript full course. You can join me for free on YouTube by clicking the video appearing in the top right now. So let's now go and add string operators to our BMI project. So at the moment in our project, we're just outputting the BMI number. What I'd like to instead do is make this a bit more of a friendly sentence. So inside our console.log, I'm going to go add some backticks. I'm going to type your BMI is, and then using the dollar signs and curly brackets, I'll put the BMI value there. Now I'm using temperate literals directly inside console.log. Now because this is relatively simple, I am going to do it like this. But if you really wanted to, you could declare a new variable, let result equal this, and then just put the result here. But for now, I'm going to use my temperate literals inside console.log. All right, let's check this out in the browser. All right, so it's asking for my weight in kilograms. I'll put 80, my height in meters, 1.75, and my gender, M. Let's go open up DevTools, head to the console, and you'll see we get this nice sentence, your BMI is with the calculated value. Now, just to show you a few other things, I do need to define my BMI up here because I will be using this later on in my program. But just to show you the power of these embedded expressions is that I could actually calculate the BMI directly inside here. So if I copy this calculation and paste it there and just comment this out for now, I'll refresh, 80 kilograms, 1.75 M, you'll see that we're able to output the same result, where inside the embedded expression, the BMI is being calculated. All right, I'm just going to put it back to how it was. So you can see that temperate literals make it really easy to work with numbers and strings to output text in the console, and more importantly, it will allow us to properly output text on our web page in more advanced topics we'll explore later. If you've enjoyed this style of teaching and are looking at mastering JavaScript, you can join me in my JavaScript full course, which is available for free on my channel. The course is designed for complete beginners and covers everything you need to know to code JavaScript at a professional level. In the course, you'll experience the same high-quality teaching and build a whole range of real-life projects from scratch. Join me today and also make sure to subscribe to the channel to stay in the loop with new releases. See you in the JavaScript full course.